Okay, so we are starting to talk about the Big Bang Theory, and one of the things you have to understand or recognize is how all of this matter in the universe came about. So you basically got, you know, the hard part about this to believe, is that everything came from that speck. The speck exploded, the light moved in all directions, right? And as that light from the explosion is moving, it has a cooling effect. So anytime you expand or release pressure, it's going to cool. Anytime you put things under pressure, it's going to get warmer. So as these light waves travel through space, they cool and they formed matter. Okay? And the simplest form of matter that you can have is going to be hydrogen. Now, I'm not going to get all into hydrogen, exactly what it is, but you do need to recognize it as the most simple particle, right? So all atoms are going to be, containing a proton. Okay, they may also have an electron, or they may also have a neutron, right? So a proton is the main thing that they have to have. It's actually got a positive charge. The electron, something that they could have, it has a negative charge. And the neutron, the key word there, the root word is neutral, it has no charge, right? Um, and these have different masses, okay? So the main thing you have to realize is that protons have a mass of 1 AMU, which means atomic mass unit, okay? The neutron also has 1 AMU. So these two are pretty heavy. The electron is very, very, very small, 1/1840th AMU. It doesn't even hit the scale really, so we don't even count it towards the real mass. Um, I don't want to get into chemistry with you though and start talking too much about it. I want you to understand that hydrogen is simply going to be, according to our periodic table, capital H. It has an atomic mass of 1 and an atomic number of 1. The atomic number is the number of protons. Okay, I'm sorry, this is the atomic number. They're the same for this one. Okay, and I used too big a marker. So the atomic number is simply the number of protons. The mass number is going to be the number of protons plus the number of neutrons. So as you can see here, hydrogen has no neutrons because 1 plus 0 is going to be 1. And it has to have a proton in order to be an atom, right? So really, if we could see this, it would simply have a proton in the center at the nucleus, and it would have 1 electron floating around outside of it. So it's as simple as it can get, right? The next atom is going to be helium. Right? And helium is going to have an atomic number of 2. So here's our periodic table box. where we store all this information. It's going to have a symbol of Ag. It is going to have an atomic number of 2, right? Which means 2 protons, right? But its atomic mass is going to be 4. So that's going to be 2 protons plus how many neutrons? Well, we must have 2 neutrons, right? So helium is simply a gas with an atomic number of 2, whereas hydrogen was the lightest and simplest element with an atomic number of 1. So let's jump back up here, that in here, lightest element or atom. The atomic number of 1. Now, if the cooling energy formed protons, which actually is going to be our hydrogen, then we have to figure out how do we make this helium from the hydrogen. And that's where nuclear fusion comes in. We have nuclear fusion. And nuclear fusion is going to be the joining of 2 or more elements to form larger atoms. So joining out atoms of simple elements to form larger atoms. Okay, so if we're going to make helium, we could have a hydrogen plus a hydrogen, right? So that's going to be 1 plus 1. That's only going to give us 2 protons, but our mass would only be 2. So when we have this happening, it's actually going to not stop here. It actually has to get a mass of 4. So how do we get 4 AMU? Well, we're going to need 4 AMU. We're going to need 4 of these hydrogen to bond, and 2 of those protons have to become neutrons through nuclear fusion. So we're going to have hydrogen plus hydrogen plus hydrogen plus hydrogen equals that new atom of helium, right? So we're going to have 1 plus 1 plus 1 plus 1 equals a new mass of 4. Okay, so it's going to take 4 hydrogen to make a helium using nuclear fusion, right? So that's the principle behind how do we get from small elements to larger elements. Now, if we take this helium and infuse another hydrogen to it, we'll now have something with a mass of 5. And that's going to be a new element because it'll have 3 protons and 2 neutrons. That will be lithium, which will be a new element. Okay? So basically, we take small things, put them together, and this requires a lot of heat and pressure, right? And so we've got these clouds of hydrogen gas that form, and they have to be pulled into itself. Okay, this is where gravity plays in. Okay, so we're going to get gravity in there, and finally, when it's enough heat and pressure, then we finally get fusion occurring in the center. We usually refer to that as the star, because this is what is going to fuel the stars. All right, that's it for today. I just wanted to go into hydrogen, helium, understand which is simple, which is larger, and that it takes 4 hydrogen to equal helium in nuclear fusion.